Which hypothesis test? Our objective: determine the appropriate hypothesis test to perform. Well, it's all going to boil down to which parameter is addressed in the hypothesis. Are we talking about the proportion? In which case we're dealing with a lot of qualitative data, yes, no, approve, disapprove, and that type of thing. Proportion, the parameter, population parameter, of course, is P. Or are we talking about the mean, which deals with quantitative data? The population mean, of course, is mu. If the parameter being addressed is the proportion, we want to note the sample size needs to be greater. This expression needs to be greater than or equal to 10. Let me get up here so everybody can see what we're doing here. There we go. And the sample size must be less than or equal to 5% of the population size. And then we're going to use the normal distribution stat, proportion stats, one sample with summary from StatCrunch. And we need to know the number of successes, what we define as success, and the sample size. If NP times 1 minus P is less than 10, we're going to go to the binomial distribution in StatCrunch under Stat Calculator Binomial. If we're talking about the population mean, quantitative data, either the sample size needs to be large enough or the data must come from a population that is normally distributed. If neither of those two things are met, we need to do a bit of work ourselves with the QQ plot and the outliers to see if we have a normal distribution. If one of those two things is met, we then use the normal distribution t-stats one sample. We'll use with data if we have raw data. We'll use with summary if we have summarized data. And we need to know the sample mean, x bar, the sample standard deviation, s, and the sample size, n. Let's take a look at a couple of examples. And let's get Coleman to the right piece of paper. Okay, a certain vehicle emission inspection station advertises that the mean wait time, okay, let's pause here. The mean wait time, we already know this is going to be dealing with population means because it says the mean wait time. For customers is less than 6 minutes. We can also pause here, and our time is going to be numerical data, so we're definitely dealing with quantitative data, so we're back to the mean. A local resident wants to test this claim and collects a random sample of 49 wait times for customers at the testing center. He finds that the sample mean, again another use of the word mean, is 5.38 minutes with a standard deviation of 2.2 minutes. Does the sample evidence support the inspection station's claim? Okay, his claim is less than 6 minutes. Use the 0.01 level of significance to test the advertised claim that the mean wait time is less than 6 minutes. Okay, number one, conditions. We're talking about a population mean, so we need to be told the population is normally distributed, or we need a large enough sample size. Well, our sample size is 49. That is greater than or equal to 30. We get to move on. Number two, null hypothesis and alternative hypothesis. Our null hypothesis is always an equation of equality, a statement of equality, and equal to 6 minutes. Okay? Is it equal to 6 minutes? And we want to test the claim, and our alternative is less than 6 minutes. Okay, our null is always a statement of equality. And the claim here, the alternative is it less than 6 minutes? There we have it. 3, what is our level of significance? In this case, we want to be at a 0.01 level of significance. 4, we need to know for our sample, we need to know the sample mean. Well, we're told that is 5.38 minutes. We need to know our sample standard deviation, which we're told is 2.2 minutes. And again, with me, I use a cursive S. Otherwise, my S's look like 5s. And our sample size we already know is 49. So we're ready to go with StatCrunch to get our p-value. And remember our statement, if the p-value is low, the null must go. Let's see what the p-value is. So we're going to go into StatCrunch. We're going to go into Stat, and we're talking t-stats. This is a mean, so go into t-stats, which is right here. And we already, we're doing a one sample, and we already have the data summarized. Sample mean, 5.38. Sample standard deviation, 2.2. Sample size was 49. Okay, we're doing a hypothesis test for mu. Our null hypothesis, our statement of equality, I got that in there, is equals 6 minutes. We need to change our default from not equals to less than. This is a left-tailed test, and it autofills the 6 in for us, and we can press compute. And there's our sample mean. We can check that. All right, we want to note our t-stat, negative 1.973, in case the homework asks for it. Again, we're not concerning ourselves with that chart because StatCrunch is much more accurate. Our p-value, 0.0272. Okay, we're going to come back over to here. And we're going to say, all right, we got a p-value equal to 0.0272. And we want to just note our t-stat also can be written as t sub 0, negative 1.973 to the thousandth. Okay, step 5, unusual. Okay, unusual is our p-value 0.0272. Is that less than our level of significance, our alpha, 0.01? And the answer is no, it's not. It is greater. It is greater. Okay, so if our p value is low, the null must go. Well, the null is not going to go anywhere. Okay, the null is going to fly in this case. So, step 6, our conclusion with a 0.0 level of significance. We always write our conclusion with respect to the alternative hypothesis. So there's not enough evidence to conclude that this is true. There is not enough evidence to conclude the mean time is less than 6 minutes. Okay, again, we always write our conclusion by focusing on the alternative hypothesis. Okay, so the P was too high, so the null will fly. We fail to reject the null. Fail to reject the null hypothesis. Okay, we failed to reject the null. So there's an example for a mean. Let's now do an example for a proportion. Okay, and now notice in your example for the mean, we had the mean time given. We had lots of uses of the word mean. And so we want to kind of keep that in mind. Proportion is this either or possibilities, okay, or non-numerical data in which calculating the mean has no meaning or can't be done. A coin is tossed 200 times. Of the 200 tosses, 116 were heads. Determine if, for this coin, more than half of the tosses will be heads at the 0.05 level of significance. Well, this is a head or not a head. So we're dealing with a proportion. Okay, let's just make a note of that. Head or no head, two choices. Okay, means, I don't need a comma there. That means proportion. We have two choices. A head or no head. We can't do a lot of math with head or no head. So we're dealing with a proportion. Okay, first off, n times p times 1 minus p. Well, our sample size is 200. Okay, the odds of getting a head is 0.5. Okay, you might want to note that. P equals 0.5 because we know that with a coin, getting a head occurs half of the time, times 1 minus 0.5. And this gives us 50, which is certainly greater than or equal to 10. Now, is the sample size larger than 5% of the population size? Well, 200 tosses is certainly smaller than an infinite number of tosses. Okay, so n is less than or equal to 0.05 n. Okay, that's a check. 200 tosses is less than 5% of all coin tosses. Okay, so we're good. 2, our null hypothesis is a statement of equality. P is equal to, it's not, I shouldn't say, it is that. It is, P is equal to 0.5, yes. Let me double check here, 0.5, okay. Our alternative hypothesis, we want to be more than half, so we want to be greater than 0.5. Okay, we've got that. Step 3, let's note that our sample size, excuse me, I went a little bit too fast. Our level of significance alpha is 0.05. Okay, step 4 is StatCrunch step. We want to note that we had 116 attempts and our sample size was 200. So what is our p-value? Okay, so we'll go into here and we'll go into, this is proportion stats. So get out of here, proportion stats, one sample with summary. Number of successes, well, we had 116 successes. Number of observations, we had 200. And we are testing P is 0.5, but we want to know if it's the alternative hypothesis is greater than 0.5. So I want to change this to the greater than symbol. And let's compute. Okay, and we're going to note, here's our sample proportion, 0.58. We could have calculated that. We chose not to because StatCrunch does it for us. We want to focus here. The p-value is 0.0118. That's rather small, but we'll compare it to alpha. And we want to note our z-stat, also known as z sub 0 in case the homework asks for it. We're not worrying about it, but the homework might request it. Okay, so let's go over to here. Give me a moment. Get myself hopefully straight. Our p-value was 0.0118. And we're noting that our z-stat, which is also written as z sub 0, to three decimal places with 2.263. Again, the z table The Z-chart would be making use of this, but we're letting StatCrunch do it for us. Step 5, is this unusual? Is our p-value less than our level of significance? Well, yes, it is unusual. Yes, so we reject the null. If the p-value is low, in this case low being below the level of significance, the null must go. Yes, so reject the null. Okay, so our conclusion: at the 0.5 level of significance, there is enough evidence to conclude, okay, that more than half of the tosses will be heads. Okay, as a reminder, our conclusion is based upon the alternative hypothesis. The alternative hypothesis said more than half, that you'll have heads happen more than half the time. So we can conclude that more than half of the tosses will be heads. In other words, we can conclude that this is probably not a fair coin. There is something going on with this coin. So to summarize, look for the word mean when you're dealing with population mean, and look for either proportion or for a situation where you only have two outcomes to deal with population proportions.